Hi students, in this video we are going to discuss about the two important algorithms that is those are nothing but fast Fourier transforms. Fast Fourier transforms. Okay, so to reduce the computations and to improve the performance of the DFT, we are using fast Fourier transforms. Okay, so there are two types of algorithms are there in fast Fourier transforms. That is one is a DIT, that is decimation in time algorithm, and another one is a DIF, decimation in frequency algorithm. There are two types of algorithms are there. Okay, so sometimes it is also called as radix 2, radix 2 DIT FFT algorithm, and this is also called as a radix 2 DIT, sorry, DIF FFT algorithm. Okay, now we will see one by one how it is calculated with the help of algorithm. In this video, we are going to discuss about the decimation in time algorithm, and later on we will discuss decimation in frequency algorithm in next part. Okay, so this decimation in time algorithm, which can be solved by using one example that is given by one problem. Okay, so what is the problem is here? Compute um, the 8 point DFT, okay, of the sequence which is given by x of n is equal to 1, and this 1 is existed when n is existed between 0 to 7, and 0 otherwise condition. Okay, so to solve this one by using DIT, decimation in time algorithm, by using DIT, decimation in time algorithm. Okay, so this is the problem. Now we are going to solve this problem by using uh, step-by-step processor. So as we know that it is consisting of 10 steps. Now we will discuss the first and stepwise. Okay, so that is the first step. So what is our first step? Okay, so the number of input samples, the number of input samples. Okay, so which is given by n is equal to 2 to the power of m, where m is nothing but integer. Okay, m is nothing but integer. So before that, we need to define the sequence. That the sequence x of n is equal to, okay. So this x of n existed when n is existing between 0 to 7. Okay. So here 1, 1, 1, 1, 1, 1, 1, 1, all are ones. Okay. And remaining all cases it's 0. So I am taking only 8-point DFT. So the question is asking about 8-point DFT. So I am taking 0 to 7 points, 0 to 7 samples only. Okay, so my sequence is xfn sequence is defined as all are ones. Okay, now I would like to compute the 8-point DFT for this given sequence by using decimation in time algorithm. So now I am following the steps, the procedure for the decimation in time algorithm. Okay, so the number of input samples are given by n is equal to 2 to the power of m, where m is an integer. Okay, so we know that the number of samples are given by n is equal to 8. Okay, and this is given by 2 to the power of n. This can be 8 can be expressed in terms of 2 powers. So this is 2 power 3 and this is m. So that the value of m is equal to 3. Okay, so this is step 1. Okay, now next step. What is next step? Next step is the input sequence is shuffled through bit reverse. Okay, so step 2. So the input sequence, which is shuffled through bit reversal. Okay, so here for that to follow this step, we need to draw one table. Okay, so the table is a bit reversal process table. So here I am writing the table. So my table is okay. So for that I need to take index. Okay, and the binary representation of this index. And next, bit reversal of index. So the columns are these are nothing but bit reversal of index and bit reversal index. So these are my columns. Okay, now say my index are this is my number of samples are 8 and those are given by 0, 1, 2, 3, 4, 5, 6, 6, 7. Okay, so the binary representation of this index is 0, 0, 0 because of 3 bits enough. So m is equal to 3, so 0, 0, 1 and 0, 1, 0 and 0, 1, 1 and 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so the bit reversal of this index. Okay, so what is the binary representation which can be reversed? Okay, we are considering. So by reversing this bit reversal index, it is again 0, 0, 0. Okay, whereas coming to this this one 1, 0, 0, and after bit reversal this is equal to 0, 1, 0. Okay, so for this one 1, 1, 0, and for this one 0, 0, 1, for this one 1, 0, 1, and for this one 0, 1, 1, and for this one 1, 1, 1. And now you need to write this bit reversal index. This is 0 and this is 4 and this is 2 and this is 6. Okay, so this is 1 and this is 5 and this is 3 and this one is 7. Okay, so instead of considering the input sequence of natural order, okay, you need to consider you need to take these bit reversal order for dismation in time algorithm. Okay, this is step 2. This is step 2. Now we will see the next step. What is that? Step 3. The step 3, which is given by the step 3 with the number of stages in the flow graph. The number of stages in this flow graph, which is given by the formula m is equal to log n to the base 2. So we know that m is equal to log, what is the number of samples are how many? So 8. So this can be equal to 3 log to the base 2, which is equal to 3. So the total number of stages are 3 only for this 8-point TFT. Okay, and the next step, fourth step. What is the fourth step? Each stage consisting of a number of so there are 3 stages are there. For each stage, which is consisting of uh, n by 2 butterflies. Okay, so n by 2 butterflies. Okay, that means the number of stages are 3. The number of stages are 3. So for each stage consisting of 8 by 2, that is 4 butterflies. So 4 butterfly samples are there. Okay, so this is step 4, and now we will see step 5. Step 5, the step 5 is nothing but the input output sequence. So the step 5 sequence nothing but the inputs and outputs for each butterfly, for each butterfly, which are separated by, which are separated by, okay, 2 to the power of m minus small m minus 1 samples, small m minus 1 samples, where this small m which represents the stage index, small m which represents the stage index. Okay, so previous step we define the number, how many number of stages occur. So the total number of stages are 3. Total number of stages are 3. Okay, so when stage 1, when stage index 1, the total number of input output samples, it is given by 1 minus 1, that is equal to 2 power 0, that is equal to 1 sample. So 1 sample. For stage index 2, if it stays in this 2, okay, 2 power 2 minus 1, it is equal to 2 power 1, that is 2 samples. Okay, and for stage index is equal to 3. Okay, and the value is 2 power 3 minus 1, that is equal to 2 square, then is equal to 4 samples. That means what? So input outputs for each butterfly, they are separated by, separated by, when stage index is 1, it is separated by one sample only. Okay, if the stage index is 2, it is separated by two samples only. If stage index is 3, it is separated by four samples only. That means what? That is the meaning of the step 5. So here the inputs and outputs of each butterfly are they separated by. So for stage index 1, if stage index is equal to 1, and the inputs outputs are separated by one sample only. Okay, so that is the meaning of the step 5. Okay, now we will see step 6. The step 6 is given by the number of complex multiplication. So the total number of complex multiplications which are given by the direct formula is there, and that is n by 2 into log n to the base 2. And we know that the n value, so 8 by 2 into log 8 to the base 2. So that is equal to 4 into 3, which is equal to 12. The number of total complex multiplications required in decimation in time algorithm is 12. And the step 7, the number of complex additions, the number of complex additions which are required for this one, and that is given by n log n to the base 2. That is equal to n value is equal to 2, and log n, that is 8 base 2, that is equal to 8 into 3. So the total number of is required number of complex additions are 24, and that is step 7. Okay, now we will see step 8. What is step 8? So okay, step 8, it is most important step. Okay, so to determine the twiddle factor, the twiddle factor exponents which are given by for this decimation in time algorithm. Okay, so here this twiddle factor exponents which are a function of it is a function of the stage index, the stage index that is given by small m, and it is a formula. The twiddle factor k is given by k is given by nt 2 to the power of m, where t which is equal to 2 to the power of m minus 1 minus 1. Okay, so here this step is most important. Observe clearly. Okay, so here the t value, generally the t value uh, which is very important to determine the twiddle factor. So the t value generally it includes 0, 1, 2, 3 and so on up to 2 to the power of m minus 1 minus 1. Okay, now we need to determine the twiddle factor k, okay, for each and every stage. Let us take the stage 1. Okay, so for stage 1, okay, and the value m value stage index value is equal to 1, m value stage index value is equal to 1, so that by substituting t in the t, what is the value of m? That is value of 1 m is 1, so 1 minus 1 minus 1, that is equal to 2 power 0 minus 1, that is equal to 1 minus 1, which is equal to 0. So here the t value is 0. For stage index 1, m is equal to 1, t equal to 0. So by substituting m and t values in k, so here k is equal to nt by 2 to the power of n. So n is 8 and t is 0 and 2 to the power of m, that is equal to 0. So the k is 0. Twiddle factor k value is 0 obtained here. Okay, that is for stage 1, the twiddle factor stage 1. Okay, now see for stage 2. For stage 2, the stage index value is 2. Now t value is obtained t to the power of 2 to the power of 2 minus 1 minus 1, that is equal to 2 power 1 minus 1, that is 2 minus 1, that is value equal to 1. So here the t value 1 we should consider 0 and 1, we should consider up to the 1. Okay, so we need to consider not only 1, we should also consider 0 and also 1. Okay, that means here the t value is equal to 2 to the power of, that means t value is equal to 0, 1 and so on up to 2 to the power m minus 1 minus 1. So here after substituting the value m is equal to 2, okay, the t value we need to write up to 1. That means we need to consider 0 and also 1. Okay, so as we know that, so by substituting t is equal to 0 and we get k value is equal to directly 0. Why? Because it's formula nt by 2 to the power of m. So t is equal to 0, it's equal to 0. When t equal to 1, its value is equal to 8 into 1 by 2 to the power of 2. Why? Because what is the value of m? M value is nothing but 2 here. M value is equal to 2. So what's the value here? 8 by 4, which is equal to 2. So here in stage 2, it requires 2 k factors. When t equal to 0, the value of k is 0. When t equal to 1, the value of k is 2. Okay, so this is a very interesting point in a twiddle factor step. Okay, now see the stage 3. In stage 3, okay, so in stage 3, m is equal to m value is equal to 3 and t value is given by 2 to the power of m minus 1 minus 1. We need to consider up to this value, okay, not exact value. We need to consider up to that value. So here the value of m is equal to 3. So 2 power 3 minus 1 minus 1, that is equal to 2 square minus 1, that is equal to 3. So we need to consider up to 3. So that means 0, 1, 2, 3. Okay, so after substituting, already we know that value small m value is 3 and t has 4 values. So we need to substitute each and every value of t in k. We are getting 4 values. Okay, when t is equal to 0, and the k is given by nt by 2 to the power of m. Okay, so when t is equal to 0, k is equal to 0 also. When t equal to 1, and the k value is equal to 8 into 1 by 2 power 3. That means 8 by 8 is equal to 1. Okay, similarly when t equal to 2, okay, and the k value is equal to 8 into 2 by 2 cube, that is equal to 2. Okay, when t equal to 3, the k value is equal to 8 into 3 by 2 cube, that is equal to 3 only. Okay, so these are the stage 3. Total we have 3 stages. So for each and every 3 we determine twiddle factors, k factors. Okay, so in stage 1, if you see, observe, there is only one twiddle factor, that is k is equal to 0. For stage 2, it has 2 twiddle factors. Those are nothing but k is equal to 0 and k is equal to 2. For stage 3, it has the 4 twiddle factors. So t is equal to 0, k is equal to 0, t equal to 1, k equal to 1, t equal to 2, k equal to 2, t equal to 3, k value equal to 3. Okay, so this is the most important step in DIT algorithm. Okay, when ninth step. Okay, according to the ninth step, what is ninth step? The number of sets or sections. Okay, so the number of steps and the sections which is obtained by the number of sets or sections of butterfly in each stage, which is given by 2 to the power of m minus small m. Okay, that means in stage 1, first stage, in stage 1, okay, so here 2 power capital M value is 3 and small m value 1. For stage 1, its value 1. Okay, so the total number of butterflies are how many? 4 only. For stage 2, again the same one, 2 to the power of 3 minus 2, that is equal to 2 power 1, that is 2 butterflies only. For stage 3, okay, 2 power 3 minus 3, that is equal to 2 power 0, that is equal to 1. Okay, so the total number of sets and are sections of for each butterfly. It requires in stage 1 4 butterflies, in stage 2 2 butterflies, in stage 3 only 1 butterfly. Okay, and the last final step, that is exponential repeat factor, ERF, exponential repeat factor. Okay, so the exponential repeat factor, which is the number of times the exponent with sequence which is associated with m, which is given by, again it's the same formula, 2 to the power of m minus m. Okay, so in stage 1, the m value is equal to 1 and the capital M is equal to 3 always. So in stage 1, 2 power 3 minus 1, that is equal to 4. Okay, so the twiddle factor which is repeated by 4 times. Okay, for stage 2, okay, m value equal to 2, And so the exponential repeat factor EF is equal to 2 3 power 2, that is equal to 2 only. So the twiddle factor repeated 2 times. For stage 3, m value is equal to 3, m value is equal to 3, so 2 power 3 minus 3, that is equal to 2 power 0, that is 1. So exponential repeat factor is which is repeated only one single time. Okay, so these are the 10 steps. Now the most important step is which is nothing but a twiddle factor. Okay, so twiddle factor. Okay, how to determine? So basically, the twiddle factor is nothing but which is represented Wn and k. Okay, so which is nothing but e to the power of minus j 2 pi by n and k sample. Okay, so normally we represent it. Okay, now see this is one. Okay, or generally we it is okay. So Wn and k, which is equal to e to the power of minus j 2 pi k by n. Okay, so here this one. So here for this problem we use this type of notation. Okay, so when stage 1 the k value is equal to 0, so Wn of 0, that is equal to e to the power of 0, so which value is equal to 1. So the twiddle factor value is equal to 1. Okay, and for stage 2 it has two twiddle factors. One is k 0, so the twiddle factor again its value is equal to 0. And when k is equal to, what is another value? When k is equal to uh, 1. Okay, now. So when k is, what is a factor here? In stage 2, it requires, sorry, and stage 2, it requires two twiddle factors. Okay, so here k is equal to 2. So k is equal to 2 and wn to the whole to the 2, that is equal to e to the power of minus j 2 pi by 8 into 2. Okay, that is equal to e to the power of minus j pi by 2. Okay, so if we expand this one, this is cos pi by 2 minus j sine pi by 2, minus j sine pi by 2. Okay, so cos 90, that is 0, minus sine 91, so its value is equal to minus j. Okay, and finally in stage 3 and the twiddle factors are k is equal to 0, so the wn whole to the power of 0 is equal to 0, and k is equal to 1, k is equal to 1, so its value is equal to wn whole to the power of 1, it is equal to e to the power of minus j 2 pi by 8 into 1. Okay, its value is equal to e to the power of minus j pi by 4, which is nothing but cos pi by 4 minus j sine pi by 4. Okay, that is, which is nothing but its value is equal to 0.707 minus j sine and 0.707. Okay, and for k equal to 2 already we derived reason just now, so its value equal to minus j. Okay, for k equal to 3, so wn whole to the power of 3, that is it is e to the power of minus j 2 pi by 8. Basically, what is the value of n? N value is equal to 8. Okay, so we can write as a w8 okay, so into 3, which is equal to e to the power of minus j 3 pi by 4, and which is equal to cos 3 pi by 4 minus j sine 3 pi by 4. Okay, and its value is equal to minus 0.707 minus j 0.707. Okay, so like this way we determine the twiddle factors. Now the actual step is butterfly diagram. In butterfly diagram, okay, how can we calculate this butterfly diagram in uh, displacement algorithm? Okay, in DIT the actual butterfly diagram is like this way. Okay, so here the twiddle factor is there. So here A and B, these are the inputs, and the outputs of this one. Okay, and see this twiddle factor which is multiplied with B first, and okay, after the product, this product one time it is added with A, which gives the value, that is A plus B into Wn whole to the power of k, this value. For this one, A minus B into Wn whole to the power of k. So like this way, we are going to determine the displacement time algorithm butterfly based on by using. Okay, so if A and B is there, So that first of all the trivial factor which is multiplied with b. Okay, one time the product which is add with a which gives one output, that is node on top side. Okay, and another one is representation that another one is the product which is subtract from a, that is you should write in bottom side. Okay, now see the now actual the algorithm based on that algorithm, so according to the, okay, so this is very very important last step. So here for that, first of all you should take the input. So here we should take a input. So actually according to the step 2, so you should take a bit reverse ladder. You should take bit reverse ladder. So that's why x of 0, so x of 4 and x of 2, x of 6 and x of 1 and x of 5, x of 3 and small x of 7, all are small x. Okay, so all sample values are 1 1 1 1 1 1 1 1. Okay, so all these samples, now see all the samples are there. So this is 0. So according to the step 3, what is the, which step it is? Step 5. So according to step 5, what is step 5? Inputs and outputs for each butterfly which are separated by 2 to the power of m minus 1 samples. So for first case, so the input and output separated by one sample only. Okay, so the inputs and outputs are separated by one sample only. So here to make it our convenience, see. So the input is separated by output one sample. Okay, so this is one sample, this is one sample. So input and one output. Okay, input and output. So this is stage 1. This is stage 1. So stage 1. Stage 1. In stage 1, what is twiddle factor? Twiddle factor is a W8 whole to the power of 0. So W8 whole to the power of 0 and W8 whole to the power of 0 and W8 whole to the power of 0. So what is the value of W8 whole to the power of 0? Its value is equal to 1. Its value is equal to 1. Okay. Now, according to the butterfly diagram, this 1 is multiplied with this 1. Okay. So this 1 is multiplied with this 1. Okay. And after the result, that result is obtained. That result is one time it is added with this one, and another time it is subtracted with this one. Okay. So here, for the first time, I would like to write here. So here, x of 0 plus x of 4 into W8 whole to the power of 0. Okay, and this is x of 0 minus x of 4 into W8 whole to the power of 0. What is the value here? So when x of 0 is 1, which is added with this 1, and this value is equal to 1. So what is the value here? It is obtained 2. So for this 1 minus 1 into 1, its value is equal to 0. Its value is equal to 0. Okay, am I right? And its value is equal to 0. Okay, now say okay, so this x of 0 minus x of 4 into W8 whole to the power of 0. So that is 1 minus 1 into 1, which is equal to 0. Okay. Similarly, so here also we get 2, 0, 2, 0, 2, 0. The same procedure, the same procedure. Okay. Now I am using my eraser for more clarification. For better understanding, you should add, okay. So this value is equal to 2, 0. Okay. So this is stage 1 is completed now. Stage 1 is completed now. Okay. Now we are entering into the stage 2. stage 2. Okay, for stage 2, okay, so input outputs are sampled by two samples. So here this is input, and this input is separated by two samples. That's why we are taking two samples difference here. Okay, and this input is sampled by two samples only. Okay, now this sample is connected like this way, and this sample is connected to like this way. So yeah, this input is sent this one, and like it is like this way, and this is connected this is, and this is connected this one. So yeah, butterworth diagram. So this is stage 2. This is stage 2. Okay, in stage 2, my twiddle factors are w8 to the power of 0 and w8 to the power of 2, and w8 to the power of 0 and w8 to the power of 2. Okay, so in stage 2, the w8 per value is equal to, what is the value? Its value is equal to 1, and this value is equal to minus j. In g, this value is equal to 1, this is minus j. Okay, now you are following the same approach. Okay, so here this 1 is multiplied with 2, and this is added. So after adding, the result is 4, and this 2 and 2 which is subtracted, so the result is 0. So 0, 0, so 0 and 0. Similarly for this 2 and 2, so we are getting 4 added. One time it is added, so its value is equal to 4, and one time it is subtracted, its value is equal to 0. So this already 0 is there, here 0 is, so its value is equal to 0 and 0. Okay, so this stage 2 is also over. Now, and final stage is stage 3. This is the last stage. Okay, so last stage. So for stage 3, input output samples are separated by 4 samples. So 4 samples, 1, 2, 3, 4. Okay, so you should connect here 1, 2, 3, 4. Okay, and connect here, and connect here, and this is connected here. Okay, and this is connected here, connected here, connected here, is connected here. Okay, so here my twiddle factors are w8 to the power of 0 and w8 to the power of 1 and w8 to the power of 2 and w8 to the power of 3. Okay, so here the w8 power is 0, and this is w8 to the power of 1, which is nothing but 0.707 value. So you should okay, just remember this value. So its value is equal to 0.707 plus j into 0.707. Okay, so this is factor. So this is not minus, this is minus, and this value is equal to minus j, and this value is equal to minus 0.0 plus minus of j into 0.707. Okay, so after again the same step, 4 plus 4 is equal to 8. Okay, and this 4 minus 4 is equal to 0. Okay, and remaining all zeros, so 0, 0, 0, and this is 0, and here also 0, 0. So finally my x of k is obtained. So x of k is obtained 8, 0, 0, 0, 0, 0, 0. So this is my answer. Okay, so like this way we are going to perform this decimation in time algorithm, that is by using DIT algorithm. We are performing discrete Fourier transform by using decimation time algorithm. Okay, thank you.